Analytics Funners, welcome to Analytics Fun. In this video, we will do a case study on Python involving regression. Okay, so in this particular video, we will start from very basic. That is, we will first import the libraries in Python. Then in step 2, we will import the dataset into our Python environment. And then in step 3, we will do exploratory data analysis, also known as EDA. In step 4, we will do the univariate analysis, that is treating individual columns as a one column and doing the analysis on that. Then we will do a bivariate analysis. Then we will prepare the data for our model. In the step 7, we will do the modeling. We will use various kind of machine learning algorithms. This is a regression problem, so we will use various kind of regression techniques such as linear regression, SVR regression, that is support vector regression, decision tree regression, random forest regression, and artificial neural network. And we will create the model from all these regression types. And then in the step 8, we will evaluate the performance of our model and basically find out which one is the best regression technique for our current scenario or for our current data set. So let us move ahead. Now let us start with the problem statement. So I have this problem statement. Let me read this problem statement. So you are working as a data scientist in an automobile organization, and you would like to develop a model to predict the total amount that customers are willing to pay for the new car. So if a new car is, someone want to buy a new car, so how much amount that the customer are going to pay for that particular new car. And this particular information will be used by the organization to do the targeted marketing based on the customer profile. So if it is a very good customer profile, a rich customer, then like company can target a premium car for that particular customer. And if the customer salary is not very high, it's in a very affordable range, then company will target the affordable car or the lower segment car to them. And we are given the following attributes for the customer, which is customer name, customer email, their country, their gender, the age, annual salary, credit card, and net worth. So these information which are in the from 1st to 5, it is known as demographics information, because this is telling me about the demographic of that customer, their name, email, where they live, their country, gender, age. And in the 6th, 7th, 8th point, these are known as financial information. Financial information such as annual salary, credit card debt, and net worth. Net worth is how much assets they have minus that liability they owe to the bank or the other creditors. And the objective is very clear, that how much customers are willing to pay the car purchase amount for the new vehicle. So this is our problem statement. Now let us go through the data set. So this is my data set. I have customer name with me. I have their email address and their country. Predominantly I can see it is USA, but like when we load into the model, we'll see like how this is a split of between the various countries. Gender, it is 0 and 1. So it is also given in the problem statement that 1 indicates male and 0 indicates female. And their age of the customer is given, annual salary in dollars, and credit card debt in dollars, net worth, asset minus liability in dollars, and the car purchase amount is also given. So this is already given for the given set of customers. So we have this historical data for our previous customers, and we know that how much amount worth car they have purchased according to their previous history. So these are our actual customers, and we will use the data of our historical customers to predict the potential car purchase amount for any new customer. So we need to predict this particular variable, which is in I, based on the information given in A to H. Okay, so this type of algorithm where you have the target variable or the dependent variable already with you, okay, and you use this to train your model, it is known as supervised learning algorithm. Okay, and in supervised learning algorithm, you have two types of classifications, two types of categories. One is the regression analysis. In the regression analysis, you have to predict the actual quantitative variable. For example, here you can see that it is a continuous value and you need to predict it. So that's why it is a regression problem, because you are predicting a continuous value in this analysis. There is another type of machine learning algorithm classification in supervised only, which is known as classification techniques, which categorize the data into different categories. For example, whether the customer will purchase or not, yes or no, this kind of category. So this kind of category is known as classification technique. And then there in the unsupervised, you do not have this target variable, which is known as clustering, where you do not have the target variable and you just have to segment this customer, maybe like group this customer into various kind of cluster. So that is known as clustering. But that was like the different type of machine learning algorithm, like machine learning techniques we have in general. Now let us go back to the problem statement. So we will first start with the importing of the libraries in Python. So let us open Google Collaboratory in our system. I am on the Google. You just have to write Google Colab and open this in new tab. And you can create a new notebook. So I have opened the new notebook and I can rename my notebook such as car purchase amount prediction. Now in this one we have a code and a text cell. So we will first input a text cell. We will delete this code cell and we will write import libraries. And then we will import a code cell and we will start writing our code. So now we will start writing our code. So we will write import numpy as np. So numpy is a Python library used for numerical analysis. And when I write as np, that means I am defining a shortcut for the numpy, so that I do not have to write numpy again and again, and I can refer to this np. So this is a very standard shortcut which we write as np. So I would recommend you follow the same shortcut so that you are well aware with the industry standards. So now we'll enter, we'll write import pandas as pd. Pandas is a library used for data frame creation or data frame manipulation. Data frame is just like a Excel for a Python. Okay, so you are just creating that Excel in the Python and doing some kind of manipulation with that. So you can understand it like that. Then we will enter again import matplotlib.pyplot as plt. This matplotlib.pyplot library is used for basic type of visualizations. So if you want to visualize your data in terms of like say bar plot, scatter plot, line plot, or any other type of basic visualization, you can use this matplotlib. We'll have one more library which is import seaborn as SNS. Seaborn library is used for advanced visualization. For advanced visualization, it is used. Matplotlib was for basic visualization. Seaborn is for advanced visualization. So these four libraries we are going to use for our analysis. So as we have already coded this in the Jupyter notebook, and I have already explained that pandas is used for table or a data frame manipulation. NumPy is used for numerical analysis. Matplotlib.pyplot is used for basic visualization, and seaborn is used for advanced visualization. And this is the code which we have already implemented in our Jupyter node, in our Google Collaboratory. Now the next step will be to import the data set into our environment, which is this one, importing of the data set. Okay, so if you have basic knowledge of Python, you will find this command very familiar with you. So let's start with the importing of the data set. But before that, we will add a text cell here. We will write import data set. And you can also like bold this if you want to bold it like this and add a quote cell. Now we will import Excel file first into the Google Colab repository, and then we will call that file into this particular session. So to import a file into the Google Colab repository, go here in this file. It is showing connecting to our runtime to enable file browsing. So let's wait for 5 to 10 seconds. Now it is connected. Now you can upload the file. Go to the files and I have that file in the case study 1 folder, which is car purchasing data. I have also provided this file in the description below. So now it says that reminder uploaded file will get deleted when this runtime is recycled. Okay, no issues. Like this particular file will be only in this particular session. It will get deleted when we like close this session. Okay, we click on OK and this file is here. Okay, so now if you want to like see this file, you can double click on this file. On the right hand side, it will take some time to load it. So you can see like this particular file, we have customer name, customer email and everything, and 500 entries are here, and it is showing by default 10 per page. So 10 entries as you can see per page, and there are 50 pages. So you can click on any page to go to that particular page. Okay, so this is the preview window. Now we will import the dataset into our Google Colab environment. We will write dataset is equal to pd.read_csv. Read_csv is used to read any CSV file, and we are using pandas as pd. So pd is a shortcut for pandas, and read_csv is a function of panda. Okay, and we need to write the path of that file. So that file is in the Jupyter notebook and in the Google Colab environment. We will like click on this 3-dot menu and copy the path, and we'll paste this path here, Control V, and we'll insert it in a quotes, single quotes, and run it. It is giving error because name PD is not defined. So I have not run this. First you run this, then you run this. Now it's fine, perfectly running fine. Now I have loaded the data set into my Google Colab environment.